Hey everyone, welcome to Gradegetter. My name is Taylor, and today we are continuing our series of videos where we work through a practice test for the SAT. This series is designed to go through a sample math test of the SAT to help you get a feel for what kind of questions will be on the test and how to study for them. Alright, let's make the SAT make sense. In part 1 of this series, we introduced the SAT math test, and we actually worked through the first couple of problems together. We are taking our time working through these questions so that you know the concepts of these problems and how to solve them. Today, we are picking up where we left off from our last video. Now, a quick heads up for you before we get going on these problems. All the problems in this video, you are allowed to use a calculator to solve. Remember, the SAT is divided up into two sections for the math test. The first section you're allowed to use a calculator, the second section you're not allowed to use a calculator. So be sure you know when you are and are not allowed to use a calculator, but for the sake of this video, all of the problems we are going to solve, you are allowed to use a calculator. So be sure to use that as a resource if you need it. Okay, so for this problem, we're given this equation here. We've got, looks like two variables, D and A, so that's interesting. Let's see what they ask us to solve for. It says, if the equation above has infinitely many solutions for D, then what is the value of A? Okay, well, if there's infinitely many solutions for the equation above, what that means is that the expression on the left side of the equal sign needs to equal the expression on the right side of the equal sign. So I think what I'm going to do is I'm going to rewrite our equation, and then I'm going to simplify the left-hand side of the equation and then the right-hand side of the equation and see how I can make them equal to each other. So let's do that. Okay, so I've rewritten my equation here. Haven't changed anything. All I've done is rewritten the left and the right-hand side in different colors just to kind of keep track of them. So first, let's simplify the left side of this equation, if possible. The first thing I notice we could do is combine like terms. I've got a D and a D here. So 8D minus D is going to be 7D, and I still have my plus 10 over 3. And that's still going to equal the right-hand side of the equation. I don't think there's anything else I can simplify here, so next I'm going to work on simplifying the right-hand side of the equation. And I think I'm going to distribute this D in here. So D times 3 is 3D, and then D times 4 is 4D, plus my A, all over 3. And again, I could simplify this even more. I could combine like terms here. 3D plus 4D is 7D. So 7D plus A all over 3 still equals the left-hand side of my equation. Okay, now remember, for it to have infinitely many solutions, the left-hand side of my equation needs to equal the right-hand side of my equation. Well, just looking at it, these things are really similar, right? I've got a 7D, all over 3, and 3. All that's missing is this plus 10, right? I've got a plus 10 on the left-hand side and a plus A on a right-hand side. Well, then it kind of is pretty obvious what A needs to be. A should be this plus 10 here in order for the left-hand side to match the right-hand side. So that's going to be my answer. A should equal 10 for there to be infinitely many solutions. So our correct choice is letter B. Alright, our next problem says that environmentalists have been monitoring the area of a glacier in Canada. The glacier is slowly shrinking. The glacier originally occupied 15,000 square miles. That's what original area. But after 2 years of monitoring the glacier, the scientists document that the area of the glacier is now 14,910 square miles. And this was after 2 years. If y is the number of years since monitoring began, which function or which equation best describes the glacier's area as a function of time? So when trying to come up for an equation or a function, I think it's most helpful to figure out what your variables represent. So first of all, g is going to be the glacier's area, and y is going to be, I think they say y is the number of years since monitoring began. So y is going to be number of years. So when y was 0, right, which is when they first started monitoring the area of the glacier, at 0 years, the area of our glacier was 15,000 square miles. So miles squared at 0 years. And then after 2 years, so y equals 2, the area of the glacier became 14,910 miles squared. So another way of writing this, if g is a function of y, g of 0 should equal 15,000. Right? That's what this expression means here. And then g of 2 should be 14,910. And so we have different options that we could choose from to plug in our equations, or our values, I should say. So remember, for this portion of the test, we can use a calculator, which is really great. So I'm going to bring up my calculator here, and then I'm going to type in our y values into each one of these equations, right, for y, and see if I get the correct output. So my input is going to be 0, should have an expected output of 15,000, and my input of 2 has an expected output of 14,910. So let's see which of these equations correctly takes my input and gives me the right output. So for my first one, right, we're going to try A. My input of 0, y equals 0, is 15,000 times 1 over 0. Okay, well, I'm not allowed to divide any number by 0, so this isn't going to work automatically. A is out. Okay, so let's go to our next problem, which is 15,000 times. So next, let's try B. So g of y equals 15,000 times 0.003 to the y. So if I plug in 2 for y, I'll get 15,000 times 0.003 to the second power, and I should get 14,910. I'm going to plug this into my calculator, and let's see if that's what I get. So 0.003 squared, right, that's to the second power, times 15,000 gives me a really tiny number, 0.135. So that's not correct either. B is out. So now let's go to C. So C has this equation, g of y equals 15,000 times 0.997 to the y. And I'm going to test this value again, right? If my input is 2, I should get 14,910. So I'm going to plug in 2 for y. So 15,000 times 0.997 squared. So let's bring up our calculator again. So 0.997 squared times 15,000. That gives me 14,910. So yeah, this one works. When I plug in 2 into my equation, I get the expected output of 14,910. So this is going to be our correct equation. And we could double check it here. I could plug in 2 for y there, but 0.997 squared to the second power is just 0.994. It's not my expected output of 14,910. So yeah, D is out. It's probably good to double check your answers just to make sure, which we went ahead and did. But yeah, we already solved for the correct answer, which is C. So this should be our equation. We have more problems to solve, but before we move on, I just wanted to let you know that Gradegetter has a whole library of videos to help make you a better student. But if you want more personal interaction, Gradegetter also offers private one-on-one tutoring, where the first 30 minutes are free with no obligation to make sure that the tutor is a good fit for you. So if you're looking for some extra help, then head to our website at gradegetter.com. Now back to the video. Alright, our last problem for this video says that the varsity swim team at Northwest High is planning a team trip and needs to choose between Austin, Texas and Pensacola, Florida. The team takes a vote and the results of the vote are shown in the table below. So you've got juniors and their votes, right? Juniors voting for Austin, Texas is here. Juniors voting for Pensacola, Florida is here. And the same for seniors. Seniors who voted for Austin, Texas is here. Seniors who voted for Pensacola, Florida is here. So now that we know how to read the graph, it says, given the information shown above, which of the following statements is true? So let's take one of these statements one at a time. So option A says that number of juniors that prefer Pensacola, Florida, so that would be here, is twice the number of juniors that prefer Austin, Texas. Okay, well, it's actually the opposite is true, right? Half of the juniors prefer Pensacola compared to those that prefer Austin. So A is not correct, right? We're seeing which of these is true. Option B says that the seniors are more than 3 times as likely to prefer Pensacola, Florida than are the juniors. So let's look at Pensacola, Florida. And let's see the relationship between the number of seniors and the number of juniors. So 23 is more than 3 times 7, which is the number of juniors. So I think B is going to be correct. This seems like it's the correct answer. But let's keep reading. I'm going to switch colors now that we think we've got the correct answer, and go to option C. C says the number of seniors that prefer Austin, Texas is 5% more than the number of juniors that prefer Austin. Okay, so this time we're looking at Austin, Texas. So let's see, are the seniors, is this 5% more than the number of juniors that prefer Austin? So 5% more would be 5% of the juniors, so 0.05, this is 5% of the juniors, and there are 14 juniors. So let's see if this is true. We can bring up our calculator. Again, we're allowed to use it on this portion of the test. So 0.05 is 5% as a decimal of the juniors, so times 14 is 0.7. So this is 0.7. So 14 plus 0.7 is 14.7, which does not equal 19. So this statement is not true. So C is not true either. And then we're just double checking ourselves. Let's look at option D. Option D says that 1/3 of the juniors prefer Pensacola, Florida. Okay, so here's the juniors. The total amount of juniors is 14 plus 7, which is 21. So since there's 21 total juniors, that means that of those that want to go to Pensacola, Florida, 7 of the 21 want to go to Pensacola. Well, that is 7 over 21 is 1/3. So that's true as well. Okay, so it seems like D also is true. So we need to now go back to option B and see what's going on. Okay, I think where I went wrong with option B was I didn't consider all of the seniors. Like how we came up with a ratio of juniors that prefer Pensacola. Let's see if we can find the ratio of seniors that prefer Pensacola and compare that to the number of juniors who prefer Pensacola. So let's see how many total seniors there are. 19 plus 23 is 42. So there's 42 total seniors. And of those 42 seniors, 23 of the 42 prefer Pensacola. Now compare this to the juniors, right? We figured that one out of 3 juniors prefer Pensacola. So what I should have done is compared these values and see, okay, is 23 out of 42, is that 3 times greater than 1 over 3? In other words, is 23 over 42 greater or equal to 1/3 times 3? So let me put a greater than or equal to sign here. I'm going to put a question mark above. So 23 over 42 doesn't really reduce. Is that greater than or equal to 1 over 3 times 3, which is just 1? So is this true? And no, 23 over 42 it's smaller than 1. 23 divided by 42, right? It's 0.54. So this is not true actually, which means that B, I was wrong about B. B is not correct, because I wasn't taking into account all of the seniors, like how many seniors prefer Pensacola, and compare that to how many juniors prefer Pensacola. So our real correct answer should be D. And this is a good example of checking all of your possible answers, especially on problems like this where you're interpreting a table. You want to make sure you're interpreting it correctly. So I think it's worthwhile to take the extra time to go through each answer. Alright, well, you've just solved several more problems from the SAT math test. We're going to keep chipping away at these problems, so be sure to watch the next video in this series and subscribe to the channel so you stay updated on all of our content. And again, if you're looking for more personal interaction, Gradegetter offers one-on-one private tutoring, so check out our website at gradegetter.com. Thanks for watching, and until next time, God bless.